All right, so we practiced it and worked it, didn't we? Practiced and worked on this, right? Yes, between yesterday or Tuesday and today. All right, so you guys know how to write a balanced molecular equation, and then we write the complete ionic. Cross out those spectator ions. We talked about that. And what you have left is the net ionic equation. Okay, so remember we did one where we had no reaction? Yeah, why did it have no reaction? Everything canceled out. That's right. So in the net ionic, if you have one of these things, formation of precipitation or generation of a gas or a weak electrolyte or non-electrolyte, those things don't cancel out. So you'll have those formed. So that's going to help you know that you have a reaction. If everything cancels out, of course, we don't have a reaction. Now, when we're talking about the complete net ionic, we said, oh, we separate those things that completely dissociate. We write them as completely dissociated as ions, right? What were those three things? Strong electrolytes, strong acids, strong bases. Perfect. Those were the three things. You separate those three things. If it's not those three things, don't separate it. Okay? So we've talked about those soluble salts. Where do you go to look up the soluble salts? How do you know? There's the charts, right? Do we look it up in the chart? Yes, we do. How else are you going to know? Unless you've memorized the chart, you're totally welcome to do that. Otherwise, we look it up in the chart. Okay, well, what about the strong acids then? We have to talk about that. I mean, strong acids and strong bases, and we'll definitely get into more acids as we go. Okay, so we look up the soluble salts in the chart. Let's talk about acids. You guys know what an acids are, right? How do you recognize an acid? Remember we talked about that with naming? Everybody said H+. So what's the formula? Give me a formula for an acid. HCl. Okay, that's good. Give me another one. H2SO4. Excellent. And here's another one. You might know this one. HC2H3O2. Anybody know what this acid is? Acetic acid, because we know that this is the acetate polyatomic ion. You know your polyatomic ions, right? Because if I said, oh, write the equation with acetic acid, you going to be able to do that? Yeah. Okay, now remember there's hydrogens in the middle. These are the ones that are not released. Just like we said, the definition. So let's talk about definitions. There are 3 definitions of an acid, 3 definitions of a base. We're going to cover the first definition now. 1412, we'll pick up the other 2 definitions. So we're just going to learn one now. That'd be easy, just one. So an acid is a substance that releases the hydrogen ion when you dissolve it in water. Okay, that's going to be key because the other definitions are slightly different with that. So that's called the Arrhenius definition. So the Arrhenius definition is when an acid will release the hydrogen ion when dissolved in water. That's the Arrhenius definition, okay, of an acid. And the hydrogen ion that gets released from the acid is the one in the front, right? We don't lose any of these H's in the middle. It's the one in the front that goes. Some have more than one hydrogen ion that can be released. Others just have one. But it's the hydrogen ion that gets released when you put it in water. Now, you guys know the properties of acids, right? What are the properties of acids? Yeah, corrodes metals. What else? What are some properties of acids? How do they taste? Sour. You don't know? Sour? Did you taste the acids in lab? I mean, how do you know it's sour? It's sour. How do you know it's sour? It's like, oh, okay, well, there's other acids. Like, you better not be tasting the ones that have been lab, right? Okay. Just a little bit. Just a little taste. Burned my tongue, but it was okay. Yeah, okay, so acids like what? Like what tastes sour that's an acid? Lemon juice, lemons, you got citric acid, oranges, yes. How about, we talked about acetic acid. You know acetic acid is in vinegar. That's right. That's what acetic acid is. That's what gives it that sourness. Okay, so acids are sour, they corrode, they release hydrogen ions. What's the pH of an acid? Is it above 7 or below 7? Below 7. That's right. Do you know what color it turns litmus paper, by the way? Yeah, it turns. We have neutral litmus paper, which is kind of purplish, so it'll turn it pinkish red. Okay, that's the color of an acid. Okay, awesome. Those are some of the properties of an acid. Now, as we talk about acids, we said, oh, there are strong acids that completely dissociate. So we need to talk about what those strong acids are. Now, when an acid completely dissociates in water, okay, so let's put something up here, completely dissociates into the hydrogen ions and the chloride ions. Now, this hydrogen ion's in water, because that's our Arrhenius definition. Well, the hydrogen ion is just a proton. Okay, it's just a lone proton, so it's not going to be by itself. So in general, when it's in water, that hydrogen ion, since it's in water, likes to ride along. It's attracted to the oxygen with the electrons, and it will ride along on the water molecule. And when it does that, it forms what we call the hydronium ion. That was one of our polyatomic ions, right? Okay, so this is the hydronium ion. So if we use the hydronium ion, H3O+, that's the same thing as the hydrogen ion. So can we use those interchangeably? Are you guys okay with that? Hydrogen ion is the same thing as the hydronium ion, because the hydrogen ion in water turns into the hydronium ion because it's just riding along on a water molecule, right? All right. So that's the hydronium ion. Now we have some acids that completely dissociate. Those are the strong ones, completely dissociate. And then we have the weak acids, such as acetic acid, which is HC2H3O2, and then it dissociates into the hydrogen ions plus your acetate ions. But remember, it's a weak acid, so we have dynamic equilibrium going on, so we have that double arrow, dynamic equilibrium, right? That's a weak acid. Now, in our complete ionic, we can only separate which acids? The strong ones or the weak ones? Which should we say? Strong ones. So how are you going to know what the strong acids are? Okay, well, there are these 7. Just like there's 7 diatomics, there's 7 strong acids. Okay, well, you had a chart for the soluble salts, but what about the strong acids? You have to memorize those. Yay! Okay, so you do need to know these 7 strong acids. Okay, let's review naming really quick. What's the first one called? Hydrochloric acid. You put hydro with the binaries. Very good. Hydrochloric acid. Awesome. Next one. Hydrobromic. Perfect. Hydroiodic. Awesome. I like the name of that. Hydroiodic. Fun to say. Oh, we got to know those polyatomic ions now. Chloric. No hydro. Perfect. Chloric acid. Excellent. Next one. Perchloric. Oh, you guys are knowing these. Oh, exciting. Next one. Nitric acid. Very good. And last one. Sulfuric. Wonderful. Perfect. Yay. Okay, you need to know the names of these acids, as always, but you need to know the 7 strong acids. Now, notice that the binary. Take a look at the binary acids. What column are those from? Halogens, right? Halogens. Are all the halogens strong acids? How about no? What about HF? It's a weak acid. Don't get so excited about the halogens all being strong acids that you lump HF in there with it. Okay? Hydrofluoric acid is a what kind of acid? Weak. It is not a strong acid. Don't fall for that. It's not a strong acid. It is a weak acid. So you're writing the complete ionic, and how do you know if it's a weak acid or a strong acid? And how do you know if you're going to separate it or not? How are you supposed to know that? Because you remember it. Did you remember the weak acids or the strong acids? The strong, because there's only 7, right? And all the rest of them would be then weak acids. Exactly. Okay, so there's our 7 strong acids. So let's talk about the bases. All right, so bases, Arrhenius definition of a base. Give me an example of a base that you use up in lab. What's an example of a base? Sodium, NaOH, sodium hydroxide. Very good. So the Arrhenius definition of sodium hydroxide is a substance that releases OH ions. Perfect. You know those are hydroxide. Awesome. Yay. Sodium ions plus hydroxide ions. Yes, that is what sodium hydroxide will completely dissociate into, being it's a strong base. Okay, so you guys know the properties of bases? Yeah? Yeah. Like soap, you know how it feels slippery? You get a base on your hand, it feels really slippery, slimy. Okay, that's base, that slippery, slimy feeling. It will, an acid burn is like, whoa, it's burning. Okay, but a base burn is more of an irritation, and by the time you notice it, it's been on your skin a while, and so now it's destroyed the top layers of your skin, it peels off. Yeah, okay, that's it. Yeah. Yeah, I'm doing lots of times, like, oh, wow, I must have got a base. My fingers are all peeling off. But strong bases completely dissociate. So let's do another example. This one's a weak base. I do want to point this one out because you may not recognize this one. It's NH3 plus H2O because we're talking about bases dissolved in water. And how is this a base? Well, when we put that in water, we get NH4 plus and OH minus, hydroxide ion. There you go. That's our definition, isn't it? Releases hydroxide ions in water. So this is ammonia. Ammonia is a base. You might have cleaned with ammonia. Dissolves in water. Soapy feeling. Okay. So this is an example of a weak base. Now, what are the strong bases? Oh, what's the pH of a base, by the way? Above 7. Okay, so B, base, that's a B word. Base, B-A-S-E. Big pH, that's another B word. And what does it turn litmus paper? Blue. That's another B word. So all the B words go together there. Okay? All right, so what are the strong bases? Because we need to know the strong bases. We're going to use the periodic table to help us with that. The strong bases are going to be group 1A. So is sodium hydroxide considered a strong base? Yes. How about potassium hydroxide? Yes. Okay, group 1A. And heavy group 2A. Heavy group 2A. What do we mean heavy? Heavy as in big. Okay, so a bigger weight, bigger number of protons. Okay, so that's exactly right. Calcium, strontium, and barium. So the strong bases are group 1A and calcium, yeah, and we'll do heavy group 2, which is calcium, strontium, barium. You see where those are? Calcium, strontium, barium. Does everybody see that? That's the heavy group 2. Okay, those are your strong bases. Do we need to know the strong bases? Yes, we need to know the strong bases. They're easy, though, because you're like, oh, group 1A and calcium, strontium, barium. Done. All right, so those are our strong bases. Those are the things that you're going to completely separate, completely dissociate when we're doing the ionic equations. So now that we're talking about strong acids and strong bases, let's talk a little bit more about acids and bases and the reactions that they undergo. So let's talk about the reactions of acids and bases. So one of the reactions of acids and bases is neutralization. What happens with neutralization? Oh, perfect. I love that. They give salt and water. Do you guys recognize what reaction type this is? HCl plus NaOH. Which one of those 5 reaction types is that? It's one of those 5 types. It's not. Combinations is usually with they combine to make one thing. Okay, this is double displacement, right? Everybody's exchanged partners. Okay, so you got the H and the OH going together. Well, H plus OH is water. And then you have the sodium and the chloride going together. Well, that forms your salt. So this is an acid and a base. This is in a double displacement exchange or metathesis reaction. Everybody switch partners. And when you do, the H and the OH form water, and the other 2 form the salt. Now, salt, I mean, is an ionic compound, right? Not table salt, but, you know, we say ionic compound for salt. So then we can say an acid plus base gives us salt and water, always. Acid plus base gives us salt and water. Acid plus base gives us salt and water. Okay, now what we had before was hydrogen ions, and then we have hydroxide ion. Well, there takes a certain amount to neutralize that. Okay, when we neutralize it, the amount of hydrogen ions equals the amount of hydroxide ions, because they're canceling each other out, right? Okay, so it's neutralized. It's not an acid anymore. It's not a base. It's neutral. It's neither acid nor base. It's the salt and water. Okay, so we've neutralized the acid, we've neutralized the base, and we produce salt and water. All right, so that's one of the reactions that acids and bases undergo. Let's talk about another reaction that acids and bases undergo. Okay, and that's they react with certain compounds. Acids react with certain compounds to produce gases, and we need to know those. Hey, by the way, do we have any learning objectives with us? Who's got learning objectives? You do? Yeah. They're all up in here, right? Is there a, let's see, this is chapter 4. Awesome. Yeah, bringing the learning objectives to class is very helpful. Helps us know what it is that we are talking about. Awesome. Okay, let's see. One of the objectives, identify the strong acids and bases. Are you going to know that? Yeah, okay, so you're going to get that right? All right, classify a given acid as a weak or strong electrolyte. Okay, we would need to know that. But you know the strong acids and strong bases are strong electrolytes. Yeah, and the soluble salts, you know those are strong electrolytes. We've talked about that. And then predict acid-base reactions, including okay, neutralization, including those with gas formation. So are you going to have to do these? Yes. All right, so you see how we're working through those objectives? Okay, well, let's talk a little bit more about the strong acids and strong bases and strong electrolytes before we get to this reaction. I do want to point out a couple things. If I have NaC2H3O2, that's sodium acetate. That's a salt, right? It's not an acid, it's not a base, this is the salt. Okay, if you look this salt up in the chart, it's a soluble salt, right? Okay, so this is a strong electrolyte. Okay, that's a strong electrolyte. But let's look at acetic acid. Is that one of our 7 strong acids? No. So this is a strong electrolyte or a weak electrolyte? Weak. Okay, you're going to be careful about that, right? Just because it has acetate in it, is that always going to make it a strong electrolyte? No. Sometimes it's a strong electrolyte, sometimes it's a weak electrolyte. It depends. Is it in a soluble salt, or is it one of the strong acids and strong bases? That's how you're going to know. Okay, just don't get excited and think, oh yeah, it's strong here, it'll be strong there. It's not. That's not one of the 7 strong acids. Do we recognize that? Also, when we dissolve acetic acid in water, we're going to put an AQ by it. So just because it has an AQ, does that mean, oh, it's got to be strong, right? No. So don't think anything with AQ is strong. Don't fall for that either. Okay, because weak ones will also be soluble. They're just not strong. They'll be dissolved. So be careful about those acids and bases. All right. Questions about that? Well, because we've memorized the strong acids, right? And if it's one of the 7 strong acids, then we know it's strong. If it's not one of the 7, then we know it's a weak acid, right? Same thing with the strong bases, right? The strong electrolytes are soluble salts. Look it up in the chart. The memorized strong acids and the memorized strong bases. Okay? That's how you're going to know, because you have memorized those, and you can look up the soluble salts on the chart. Those are the 3 strong electrolytes. That make sense? Okay, yay, got that? Awesome. All right. Good. Well, let's talk about these reactions. These are the reactions, just like we were saying, oh, these are on the learning objectives, so let's talk about it. Reaction type. We've got sulfides, carbonates, bicarbonates, sulfites, and bisulfites. Sulfides. Okay. Intermediate. What's that? We'll talk about that in just a second. So, what is the gas that's evolved when you have any acid reacting with any of the sulfides? H2S, right. Hydrogen sulfide, right. So, let's take a look at that example. Here's your acid, HCl, reacting with any sulfide. Could be potassium sulfide, could be lithium sulfide, could be cesium sulfide, I mean any other sulfides, right? Any of the sulfides. Okay, fine. So we're going to react with the sulfides. What kind of reaction type is that? Double displacement. It's not combination. Combination always means you form one product from elements. We're not forming one product from elements. We don't have elements, and we're not forming one product, right? So this reaction type is the double displacement. Very good. What happens in double displacement? Everybody switch partners. There you go. All right, well, let's do that. Hydrogen is going to go with which one? Sulfur, yeah. And potassium is going to go with chloride. Well, there you go. Isn't that your gas right there, H2S? Okay, that's easy to remember, right? It's a double displacement reaction. An acid reacting with the sulfides produces H2S gas. But now let's look at the next two, carbonates and bicarbonates. Anything with a CO3. Yeah, and what gas does it produce? Carbon dioxide, CO2. Well, if you're trying to look at that, can you tell me what reaction type that one is? Kind of hard to say, doesn't it? This is a tricky one. Very good. It's hard to see because it looks like it could be double displacement, right? But that's not what the products end up being, is it? All right, well, let's see how we would do that. Well, the first reaction, HCl, it's actually two reaction types, K2CO3. All right, here's my acid, here's my carbonate. This is an exchange double displacement reaction, right? So when we do that, hydrogen is going to go with which one? CO3. Okay, you know what that would be. That would be H2CO3. Watch your charges. You know that CO3 2 minus, so H2CO3 plus, and then how about this one? Is it K2Cl? No, it's KCl because you remember the charges, right? Charges for ionic compounds, right? Yes, okay. Well, there it is. Now we have to balance it. Is it balanced? No. What am I going to have to do? Okay, 2 for the KCl and then 2 for the HCl. Now is it balanced? All right, so what I've done is I've done a double displacement. So this is double displacement. That's or exchange or metathesis, one of those words. Exchange. Okay, everybody switch partners and we produce this. We call that an intermediate because it goes on to produce something else. So that's what we mean by the intermediate product. Any carbonates or bicarbonates will produce this intermediate product first, and then the intermediate product goes on to do another reaction. So that one would be H2CO3, and what happens is this produces H2O plus CO2. What kind of reaction type is this one, did we say? Decomposition. Okay, so this is decomposition. So what happens is you have two reaction types, and they're combined together. So can I write in H2O and CO2 right there for the carbonic acid? And when I do, that's the products I get, isn't it? All right, so what is the gas evolved with anything with the carbonates or bicarbonates? What's the gas that we end up with? CO2. Do you see how that happened? Okay, so CO2. So anytime you recognize the carbonates and bicarbonates, you're going to get CO2. How about anytime you see sulfites and bisulfites with an acid? What gas are we going to get? Sulfides, yeah, sulfites. It's so hard to say those. Sulfides, similar. Sulfites and bisulfites would be SO2, yeah. Okay, so everybody got that? Sulfites, bisulfites, SO2. Sulfides, H2S, carbonates, bicarbonates, CO2. All right, so everybody can do those reaction types? Oh, so easy. Excellent. Okay, very good.